The morning session we're going to have with Mr. Kanat Emiroglu, who is until recently, the Managing Director of British Gas Business for the past 10 years.
Okay, good morning, everybody. It's always difficult to do the first speech. You have to wake people up, break the ice. But I'll be careful not to make any jokes. You know, I'm Turkish. The sense of humor doesn't really work here. But so my name is Kanat Emiroglu. I don't work anymore in British Gas Business. I left in the summer. I joined a private equity company, and after 20 years in the UK, I went back to Istanbul, and I have now 6 energy companies, all of which in some shape or form use the smart grid or smart grid applications or components of it. So quite an exciting market. And I also keep a role here in Boston Consulting Group. So I'm one of the 4 senior advisors globally for Boston Consulting Group's energy practice. Today, what I wanted to speak about is, I looked at all the material around smart grids, and I said, why don't I focus on the 7 challenges that smart grids have to actually solve? What are the social, economic, and industrial challenges that are out there? So I'll start from the first one, which is that energy consumption is growing. So in the next 20 years, energy consumption around the world is going to grow around 2/3. So we estimate 68%. And it's quite lopsided. In Europe, US, and Japan, it's not really growing a lot, around 20%, so quite a pedestrian growth. And in the developing world, it's much faster, with India more than doubling. And so different priorities for different countries. I'll talk a little bit about this later. The second challenge is to reduce peak demand. So because of the way we use electricity in residential homes, agriculture, commercial, and industry, military, actually peak demand in typical countries is about twice during the day as base demand. And this equation is not improving. So with the reduction in nuclear generation in some European countries, actually there's a reduction in the amount of base demand that's available, so base load that's available. And with the introduction of renewables, there's an increase in peak usage, but it comes irregularly. So what smart grids can do is shave peak demand. I think the most interesting example at the moment we're facing around the world is in Japan. In Japan, for this winter, throughout the summer, they have had emergency projects trying to reduce peak demand this winter, because without 45 gigawatts of nuclear generation, all of which is shut after the Fukushima tragedy, they had to prepare for this winter in order for some of their cities not to freeze during the winter. But peak demand remains an issue. A lot of power generation is out there just to do peak demand. And is this the best way to use our climate resources and our carbon resources? The third one is about interruptions. And some of you will be working in companies that directly solve this problem. So both interruptions in the grid and the quality of supply remains an issue. And on the right here, you see the interruptions per minute during a year in selected European countries. So things are improving, but there's a lot more to do. I mean, look where Germany is at the very bottom, running their networks really well, and some other European countries still have a way to go. And on the left side, you see the cost of interruptions. So living in the 21st century, there are certain industries that really cannot afford interruptions anymore. Maybe 30, 40 years ago, people could just accommodate it. And some industries like telephone ticket sales, for example, per hour, interruption costs them £72,000 in this country. But if you're a brokerage operation in the city and there's a power interruption, I mean, this is quite serious. So you usually have backup, etc., and those have costs too. And so smart grids play a role in reducing this and the quality of supply. Challenge 4 is the growth of distributed energy. I think a lot of people will talk about it in the next 2 days, but I just wanted to illustrate, where Germany is with the so-called Energiewende, or the change in energy use. Germany is today about 27% in distributed generation. And this is causing a lot of issues in adjusting for the grid and for consumers and for industrial users and for some of Germany's neighbors. I don't know if you read recently, the Czech Republic electricity company basically said, we're going to put a giant switch at the German border because every now and then when the wind blows in parts of Germany, our network collapses because of the surge. So what do we do with this? And smart grids plays a big role because distributed energy is here to stay and it will have to be managed. The next one is the nature of distributed energy. So in renewables, especially in wind, which is about 80% of the capital invested in new energy around Europe is in wind, comes quite irregularly. It comes irregularly in seasons, in days, and also hours in the days, which actually is almost more relevant than anything else, if you remember what the peak demand was. And so the amount of feed-in tariff from wind also is quite difficult to forecast. I'll give you one example. In the North Sea, when you have wind generation for the UK, it rises with the wind, but there have been certain instances last year where too much wind makes the wind turbines shut off. So suddenly, from a smooth increase in wind-generated production, you go back to zero. And these are really difficult things to forecast and difficult things to manage. And so smart grids or more connected, intelligent grids that use data more probabilistically and online almost in real time is crucial. The other thing about renewables is it changes the merit order. So for countries where, and this is most European countries now, where electricity prices are determined by the market, by demand and supply. So the merit order of generation matters. Those who are most expensive shut off first when demand goes down. Now that is complicated by renewables because government regulations mean some types of renewable generation have to continuously run. So as you see here, no matter how expensive they are, certain types of generation have to run, and then the normal merit order starts. So this becomes almost, think of this as half hourly, every minute, every 5 minutes, every 10 minutes. This becomes quite a big mathematical problem as renewable generations grow and the diversity of renewable generations grow, the different types of generation. The next one I want to talk about is efficiency. So consumers are still very much interested in climate change. Maybe they don't want to pay for it. On the left here, you see, in the dark green, people who would be willing to pay for it and do buy green products regularly. And then light green is sometimes buy and the others don't buy. But in general, energy efficiency has made a huge impact in the demand profile of United Kingdom. In the last 4 years, when I was in British Gas, up to this winter, we were always surprised. We always assumed that there would be energy efficiency, but we were surprised by a few percentage points each year on more energy efficient side. So people used less energy. And this is going to go on. So according to Boston Consulting Group, again, even in the US where energy efficiency is a bit patchy, if you go to Texas, they don't care very much. If you go to California, they care a lot. But in general, average consumption per capita is still set to reduce by about a third or even more than a third in the next 20 years. And smart grids have a role in this because sort of switching off the lights or stuff like that really doesn't do the energy efficiency more than a few percentage points of damage, so to say. The big energy efficiency happens through a thorough understanding of what's going on in energy, how much energy you're using versus last year versus your competitors. How much are you using for heating, cooling, lighting, and a thorough understanding of this for somebody like Walmart in the US, and an analysis enables them to actually take the right economic measures and write the business cases for further energy efficiency moves. So again, smart grids plays a big role in generating this data and being able to give the insight to companies. And the last challenge I wanted to outline was that, for companies, for large companies, and Europeans are pretty big in supplying the world in smart grid components and solutions. One of the issues is the world is in different stages. So you look at where the developing world is, they are building networks still in Brazil, in India, in China. So the expansion of the grid is really the number one issue. You look at the US, where the grid is no longer really performing from any measure you look at it, quality, interruptions, and the life scale of the equipment, the need to replace it, etc. It can only be described as a sort of non-performing grid that needs to be exchanged. So a lot will have to be put in, just ripping out old systems and putting in new ones. Whereas in Europe, I think it would be, we describe it as a kind of well-performing, mature market. So most of the stuff goes into sort of upgrading the grids and making them work in a smart manner. But how does a global company cater its different offering for different parts of the world? I think that's one of the challenges of smart grid also. So I won't bore you with explaining how today's grid works and smart grid works, but a lot of, I'm sure, people will go into much more intelligibly into the detail of it. But what fascinates me, one thing that fascinates me in smart grid is electricity storage. I want to outline that a bit, because for me, that's an issue humanity couldn't really solve yet. And if they do, and a lot of people are working on it now, how to store electricity in large quantities efficiently and be able to release it at the right time. If this happens, I think the value in smart grids is really going to grow exponentially for the countries that can manage this. It is a big market. So if you look at the transmission and distribution equipment and solutions market, this is amounts to more than 4 trillion euros for the next 20 years. So we're not talking about a small market, and it does grow in the next 10 years before it peaks, and replacement and growth of Asia sort of gives way to a more maintenance mode. And Asia is half of the market in 10 years from now, and remains so. In fact, grows a little bit more than half of the market. I think a lot of you working in global firms will know about this, but I wanted to put it in front of you for future discussions. Who dominates the transmission and distribution market today? It's the 4 big European players, ABB, Siemens, Alstom, and Schneider. But there are also a lot of smaller players, especially coming from Asia, and they're growing in niche areas. And I think smart grids, a thorough understanding of what is happening in smart grids, how they will work, how the machines will work together, is quite crucial for the big 4 to be able to retain their market shares, or for the Asians to be able to make big inroads into this market. What is interesting, though, is if you move away from the component sides of things and look at the services that are generated around smart grid, and 3 of the companies that I have in Istanbul out of 6 are focused on this. A lot of the value generated, especially in Germany, where probably smart grid is more advanced than others, a lot of the value generated is generated by smaller companies. They innovate and they find the solutions. So that's, I think, a food for thought for the larger companies that dominate the equipment market, and for utilities like my previous company, British Gas, or like for E.ON, RWE. When you look at their new energy units, it really remains almost a sort of a CEO's pet project, or a unit that perpetually loses money and is not taken seriously other than for PR and corporate governance concerns. Should it be so? I think it leaves a question in the air. So just to sum up, I think it's clear that in the next 2 days we're going to talk about smart grids, both in their role in increasing energy supply, so through renewables, distributed generation, distributed heat and power, and virtual power plants, etc., but also in terms of decreasing energy demand. And so instead of optimizing demand by shutting off people's electricity, like interruptibles in industrials, etc., we'll find better methods like demand response, etc. And in energy efficiency, the challenge for smart grids will be to generate the right insights, data-generated, statistics-generated insights that will enable business people to invest and make sure the next generation uses energy a little bit more respectfully, less callously, and more efficiently than we or I think our father's generation has used. So I'll conclude with that and invite Georg to do the second speech.